네, 여러분 안녕하십니까? 지금부터 제37회 피스바 페스티벌 세계평화의 날 기념식을 시작하겠습니다. 저는 이 시간 사회를 맡은 미래문명원의 부원장 신은희 교수입니다. 올해 피스바 페스티벌 주제는 전환문명 시대의 한반도, 가치와 철학입니다. 오늘 기념식에는 총장님을 비롯하여 이사장님, 상임이사님, 이사님, 해외 석학, 교수, 학생, 직원, 동문, 일반 시민 등 많은 분들이 함께 참석해 주셨습니다. 여러분 모두를 진심으로 환영합니다. 아무쪼록 오늘 이 뜻깊은 자리를 통해 한반도를 포함한 세계 평화의 의미를 되새기고 평화를 추구하는 모든 이들의 염원과 노력이 고귀한 결실을 맺을 수 있기를 기원해 보겠습니다. 이제 미래문명원의 이한구 원장님께서 세계평화의 날의 역사적 배경에 관해서 소개해 드리도록 하겠습니다. 여러분, 이한구 원장님을 큰 박수로 맞이해 주시기 바랍니다.
네, 안녕하십니까? UN 세계 평화의 날이 제정된 배경과 역사에 대해 말씀드리겠습니다. 잘 아시는 것처럼 오늘은 37번째 맞이하는 UN 평화의 날입니다. 오늘도 전 세계 UN 회원국과 UN 및 산하기관, 교육기관, 시민단체가 평화에 대한 인류의 염원을 되새기고 있습니다. 오늘 인종, 언어, 문화, 체제, 국적을 떠나 지구촌을 하나로 묶는 세계 공용어는 평화입니다. 그렇지만 세계 평화의 날을 누가 왜 제안했는지 아는 분은 그리 많지 않습니다. UN 회원국도 아니었고 UN이나 그 산하기관도 아니었습니다. 시민단체도 아니었습니다. UN 평화의 날은 경희대가 제안해 UN이 제정 선포한 날입니다. 지금으로부터 37년 전인 1981년 코스타리카에서 열린 제6차 세계대학 총장회의에서 경희대 설립자 미원 조영식 박사가 UN의 세계 평화의 날과 해를 정하도록 하자고 제안했습니다. 세계대학 총장회는 코스타리카 결의문을 채택했고 코스타리카 정부를 통해 UN의 의안을 상정했습니다. 당시 한국은 UN 회원국이 아니었기 때문에 코스타리카 정부의 도움을 받아야 했습니다. 당시 동서 양극 체제는 살얼음판을 걷고 있었습니다. 인류 최후의 전쟁, 즉 핵전쟁이 발발할지 모른다는 위기의식이 팽배했습니다. 인류 평화를 위해서는 냉전 체제를 해체하는 것이 절체절명의 과제였습니다. 경희가 세계 평화의 날과 해 제정을 촉구한 직접적인 이유가 여기에 있습니다. 세계 평화의 날과 해는 1981년 11월 제36차 UN 총회에서 157개 회원국이 만장일치로 통과시켰습니다. 매년 9월 셋째 주 화요일을 세계 평화의 날로, 그리고 1986년 한 해를 세계 평화의 해로 제정 선포했습니다. 세계 평화의 날은 2001년부터 9월 21일로 고정됐습니다. 세계 평화의 날과 해는 동서간 해빙 무드를 조성하는 데 일정한 기여를 한 것으로 평가되고 있습니다. 특히 1986년 세계 평화의 해를 맞아 미소 양국 지도자가 상대방 국민을 향해 평화의 메시지를 전달했고, 같은 해 양국은 1년의 군축 회담을 성사시켰습니다. 1995년 경희대를 방문한 고르바초프 전 소련 대통령은 이렇게 말했습니다. 경희가 제안해 제정된 유엔 세계 평화의 날과 해가 없었다면 지금 우리가 누리고 있는 평화로운 세계는 없었을 것이다. 인류 평화에 대한 경의의 실천적 노력은 1981년 세계 평화의 날이 제정되기 이전부터 있어 왔고 또 그 이후에도 지속적으로 확대되어 왔습니다. 경의의 창학 이념, 문화세계의 창조는 1951년 한국 전쟁의 와중에서 탄생했습니다. 일제강점, 해방과 좌우 이념 갈등, 참혹한 전쟁으로 이어지는 힘의 논리, 극단의 세계 한가운데 다시 말해 평화로부터 가장 먼 곳에서 평화의 씨앗을 뿌린 것입니다. 이후 경의는 교육과 평화를 결합하면서 정신과 물질, 인간과 자연이 조화를 이루는 문화세계의 창조를 통해 지구상 모든 존재가 평화롭게 공존하는 인류 사회를 추구해 왔습니다. 창학 초기인 1950년대 중반 전쟁으로 인해 피폐해진 인간의 각성과 무너진 공동체를 재건하기 위해 대학 울타리를 벗어나 사회 속으로 뛰어들었습니다. 1965년에는 세계대학 총장회의 창립을 주도했고 이를 기반으로 대학의 사회적 책임을 지구적으로 확대해 왔습니다. 세계 평화의 날 제정을 촉구하기 2년 전인 1979년 경의는 로마 클럽과 함께 21세기 인류 사회를 전망하는 학술 대회를 개최했으며 1982년부터는 세계 평화의 날 제정을 기념하는 국제 평화 학술 회의를 매년 개최해 왔습니다. 이 학술 회의는 2004년부터 PBF로 확대 오늘에 이르고 있습니다. 경의의 평화운동은 1984년 평화복지대학원 설립, 1987년 세계평화대백과사전 출간, 1990년 레오 르네상스 운동 등으로 이어졌습니다. 1999년 개교 50주년에는 서울 NGO 세계대회를 개최했고 2009년 개교 60주년을 맞아 세계 시민 포럼과 세계 시민 청년 포럼을 창립했습니다. 2011년에는 세계 평화의 날 제정 30주년을 맞아 유나이와 공동으로 서울과 뉴욕에서 국제회의를 개최하기도 했습니다. 2011년에는 휴머니타스 칼리지를 설립해 세계 시민을 목표로 하는 교양 교육을 전면적으로 쇄신했으며 이와 함께 사회운동의 새로운 모델을 제시하는 경의 지구사회봉사단을 설립했습니다. 이 모두가 학술과 실천의 결합을 통해 지속 가능한 인류 문명을 건설하는 데 이바지하려는 경의의 열정이고 도전입니다. 대학의 존재 이유는 더 나은 미래를 준비하는 데 있을 것입니다. 그 미래는 평화가 바탕이 될 때만 가능할 것입니다. 평화를 추구해온 경의의 짧지 않은 여정은 인류 문명의 한 이정표가 되리라 확신합니다. 감사합니다.
네, 세계 평화의 날을 역사적으로 개건해 주신 이한구 원장님 다시 한번 감사드립니다. 다음은 유엔 안토니오 구테르즈 사무총장님의 축하 영상 메시지를 함께 시청하시겠습니다. 또한 축하 영상 메시지와 함께 세계 평화의 날을 기념하여 링고스타를 비롯한 세계 각국의 뮤지션들이 헌정한 축하 음악 영상도 연이어 함께 감상하시도록 하겠습니다.
This year we mark International Day of Peace as we prepare to celebrate the 70th anniversary of the Universal Declaration of Human Rights. And this foundational document is a reminder that peace takes root when people are free from hunger, poverty and oppression and can thrive and prosper. With the Universal Declaration of Human Rights as our guide, we must ensure the achievement of the Sustainable Development Goals. I encourage you to speak up for gender equality, for inclusive societies, for climate action. Do your part at school, at work, at home. Every step counts. Let us work together to promote and defend human rights for all in the name of lasting peace for all.
We've all heard that only love conquers hate. Will we see the light before it's too late? Skies are getting dark, tears of sorrow falling. Listen to the voice and you will hear it calling. Now the time has come. Time has come for everyone to lay down all your arms and let the light of love shine on and on. You have to give a little, or you can give a lot. Let them know that they're not forgot. Let's open up our hearts, may all the violence cease. Let's all come together on this day of peace. If we are one for all and all for one, then there is only love when it's all said and done. We're living in a world that's constantly creating, so it lies within us all. The children, they are waiting. Now the time has come. Time has come for everyone to lay down all your guns and live a life of peace and love. We can make this world a better place. Love for all mankind, that's the only way. Take away the homelessness, take away the grief. Give them shelter, take them up off the street. We all know it's time. Now the time has come. Time has come for everyone to lay down all your guns. Let the light of love shine on and on. Now the time has come. Time has come for everyone to lay down all your guns. Let the light of love shine on and on. Now the time has come. Time has come for everyone to lay down all your guns and live a life of peace and love.
Peace and love.
Very nice. That sounds great.
네, 잔잔한 감동을 전해주는 축하 헌정 음악입니다. 감사합니다. 다음은 경희대학교 조인원 총장님의 기념사가 있겠습니다. 여러분 총장님을 큰 박수로 맞이해 주시기 바랍니다.
우선 말씀드리기에 앞서서 그래서 오늘은 특별한 날인 것 같습니다. 사실은 어제부터 그랬고요. 남북의 그 양 정상이 한반도에 더 크고 그 멋진 미래를 위해서 지금 평양에 계십니다. 우리 다 함께 한반도의 그 미래를 위해서 큰 성원의 박수를 한번 치고 시작을 했습니다. 오늘 자리를 함께 해주신 보코바 전 유네스코 사무총장님, 또 피터 어담스 교수님, 또 사모님이신 마리아 카사리니 박사님, 또 경의 오랜 친구인 콩고의 로베르타 바티스타 의장님, 또 와스스 세계 예술과학 아카데미 의장이신 게리 제이콥스 박사님, 그리고 토마스 윌스 교수님 참석해 주셔서 대단히 감사드립니다. 여러분 반갑습니다. 앞서 문명 원장님께서 말씀 주셨듯이 올해는 37번째 세계 평화의 날입니다. 뜻깊은 시간에 인사드릴 수 있게 되어서 큰 영광으로 생각합니다. 세계 평화의 날은 1981년 제정됐습니다. 이제 그로부터 37년이 흘렀습니다. 국제사회에는 많은 변화가 있었습니다. 기아와 빈곤, 인권, 양성평등, 환경, 기후변화와 같은 사안이 국제사회의 관심을 끌었습니다. 새천년을 맞아서 유엔이 공표한 밀레니엄 디벨롭먼트 골, 새천년 발전 목표, 또 2015년 공표한 SDG, 지속 가능한 발전 목표, 이 모두 앞서 말씀드린 인류의 공동 관심사를 반영한 매우 의미 있고 포괄적인 시대의 과제입니다. 최근에 들어서 앞서 말씀드린 그런 의제 중에서 크게 관심이 집중되고 있는 사안이 있습니다. 우리가 너무도 잘 아는, 또 어제 아주 훌륭한 그런 세션을 가졌던, 그러나 그 대처 속도가 너무 안타깝게도 느린 기후변화 문제입니다. 세상이 거꾸로 가고 있다. 전 세계에 적색 경보를 울린다. 올해 초에 목표와 결과 사이에서 큰 괴리를 강조한 구테르스 유엔 사무총장님의 신년사의 핵심 부분입니다. 지난 4월엔 또 다른 기자회견이 있었습니다. 이런 메시지를 담았습니다. 우리가 당면한 가장 체계적인 실존적인 위협은 바로 기후변화입니다. 쓰나미처럼 물려오는 방증 자료가 이를 입증합니다. 그리고 바로 지난주입니다. 유엔 본부 국제회의장에선 이런 이야기를 했습니다. 2020년까지 우리가 경로를 바꾸지 않으면 인류가 걷잡을 수 없는 기후의 재앙을 맞게 된다. 지난 수십 년간 경고와 부인, 기후변화를 둘러싼 경고와 부인 양 진영이 나누어서 많은 정치적인 다툼이 있었습니다. 그런 와중에 일반 시민들은 결론 없는 역사의 지루함, 또 정치의 비루함에 지쳐갔습니다. 현실에 매여서 또는 전문성이 부족해서 기후변화는 일상 대화에서 멀어져 갔습니다. 그러나 인류 안위에 관한 유엔 사무총장의 강경하고 지속적인 긴급 메시지는 이제 또 다른 차원으로 다가섭니다. 내 앞에 놓인 실존적 위협으로 우리의 관심을 이끌고 있습니다. 그러나 여전히 눈앞에 이해득실의 정치에 몰두하는 현실 정치가 어떻게 반응할지는 더 두고 봐야 할 일입니다. 최근 수년간 지구 평균 온도가 기상 관측 이후 가장 높은 수치를 보였습니다. 특히 올해는 유난히 북반구 지역이 무더웠습니다. 그리고 그 소식이 연일 뉴스를 탔습니다. LA 48도, 뭄바이 47도, 마드리드 48도, 동경 42도, 서울은 다 경험하셨지만 최고 온도가 올해 41도까지 올라갔습니다. 이런 이상 고온 외에도 기후 현실을 보여주는 지구적 상황은 다양합니다. 어제 우리 피터 와담스 교수님 자세하게 말씀을 해주셨지만 다시 한번 열거를 해보면 북반구 여러 지역에서 나타나는 열도움 현상, 히트도움이라고 하는 열도움 현상, 해수면 상승과 해류 교란, 더디고 굴곡이 큰 제트기류, 예상보다 빠른 극지방 해빙과 유례없는 남북극의 비 소식, 극한 기상이변을 초래하는 지구적 현실은 지구촌 많은 도시와 지역이 맞닥뜨린 기후변화의 뚜렷한 결과입니다. 그리고 그 결과는 인간이 만들어온 지구 온난화에 기인한 것입니다. 지난 4월엔 대기 중 이산화탄소 농도가 411 ppm, parts per million까지 올라갔다고 합니다. 대기 중 고밀도 이산화탄소는 지구 고온 현상과 앞서 말씀드린 기후 체계의 티핑 포인트를 무너뜨릴 가능성이 많습니다. 모두 궁금해지는 사안이 있습니다. 돌이킬 수 없는 기후 변화, 그 재앙이 언제 우리에게 닥쳐올까? 기후학자들은 산업화 이전 시기에 비해서 지구 평균 기온이 2, 3도 오르는 시점을 말합니다. 지금 이미 1도 올라갔습니다. 그 말은 앞으로 1, 2도가 더 상승하면 기후학자들이 말하는 이른바 핫하우스, 열실 지구의 궤적에 우리가 진입할지 모른다고 합니다. 이 궤도에 오르면 서식지, 경작지, 생태계가 매우 광범위하게 파괴됩니다. 해수면이 수미터에서 많게는 수십 미터까지 오를 수 있습니다. 지구의 상당 지역이 인간이 거주할 수 없는 곳으로 바뀝니다. 3년 전에 체결된 파리 기후 협약은 바로 이런 상황에 대비해서 만든 국제사회의 최소한의 노력입니다. 최소한이라고 하는 부분에 우리가 주목을 할 필요가 있을 것 같습니다. 금세기 말까지 지구 온도 상승을 산업화 이전 대비 2도 내로 제한하기 위한 그런 노력입니다. 협약이 성사되면서 아마 여러분 모두 기억하시리라고 생각하는 국제사회는 크게 환호했습니다. 그러나 환호도 잠시였습니다. 화석 연료 산업을 활성화하고 자국 경제 우선을 내세운 트럼프 행정부가 파리 협약에서 탈퇴했습니다. 과학자들은 종전의 산업화 방식을 고수할 경우, 소위 비즈니스 as usual이라고 하는 그런 방식을 고수할 경우 진화 혹은 멸절의 선택지를 내밀지 모를 급격한 기후변화가 20, 30년 내에 올지 모른다고 합니다. 어떤 사람들은 3, 40년이 고비라고 합니다. 그러나 이보다 더 훨씬 급진적인 전망이 우리를 당혹스럽게 합니다. 불과 향후 수년 또는 10년 내 인류가 그런 상황에 봉착할 수 있다는 분석도 나오고 있습니다. 모든 과학적 전망이 그렇듯이 정확한 예측을 내놓는 것은 불가능합니다. 항상 오차가 있을 수밖에 없습니다. 그러나 중요한 것은 가능성입니다. 열린 가능성입니다. 지금 방식으로 화석 연료가 사용될 경우에 인류는 큰 재앙을 맞을 수밖에 없습니다. 아마도 바로 이 점이 유엔 사무총장께서 신년에 신년사를 전 세계에 내보내면서 세상이 거꾸로 간다, 또 온 세계에 적색 경보를 올린다라고 하는 그런 강력한 메시지를 던진 이유가 아닐까 저는 개인적으로 생각해 봅니다. 몇 년 전에 옥스퍼드 대사전은 탈진실이라는 말을 그해 단어로 선정했습니다. 내가 보고 싶은 대로, 내가 해석하고 싶은 대로 주어진 현실을 그렇게 바라보는 자기 충족의 세계, self-fulfilling world가 되어 있죠. 자기 충족 세계가 탈진실 세계입니다. 기후변화에 관한 지루한 논쟁은 바로 이런 세계의 산물이 아닐까 하는 생각을 해봅니다. 기후변화는 다 아시겠지만 현상이고 과학 세계에 속합니다. 자료에 따르면 95%, 과학자의 95%가 기후변화는 진실이고 긴급한 대처를 요청한다고 보고 있습니다. 물론 온전하진 않겠지만 우리는 과학을 존중해야 합니다. 믿어야 합니다. 현실 정치의 셈법에 묻혀서 자연현상을 정치적으로 해석하는 일은 현명치 않습니다. 이와 같은 상황은 우리가 힘을 모아서 극복해야 합니다. 불행 중 다행으로 그런 가능성이 완전히 닫혀져 있지는 않습니다. 지금 미국 내에선 캘리포니아, 텍사스 주를 비롯한 많은 주에서 화석 연료를 제한하는 조치를 서두르고 있습니다. 또 눈을 세계로 돌리면 스웨덴, 노르웨이, 독일, 영국, 캐나다, 중국, 그리고 가장 큰 산유국 중 하나인 사우디아라비아까지도 화석 연료 제로를 향해서 빠른 발걸음을 재촉하고 있습니다. 이 외에도 세계엔 진취적인 길을 택하고 있는 나라가 많습니다. 그리고 그런 정치적 선택의 배경에는 깨어난 시민의식이 있습니다. 현실 정치는 시민의식과 함께 자랍니다. 시민의식이 변하면 정치는 변합니다. 종전의 관행적 방식을 넘어서려는 의식, 그 의식이 시민사회에 널리 퍼질 때 우리는 기후 재앙을 지연시킬 수 있습니다. 미래 세대의 미래를 확보할 수 있습니다. 그간 우리는 산업 문명의 길을 겪으면서 경제와 성장과 소비의 신화를 만들었습니다. 그 신화가 급격한 기후변화의 가능성을 노정했습니다. 지금은 더디게 성장할 수 있고 또 덜 풍요로울 수 있다는 삶의 지혜, 삶의 철학이 필요한 때입니다. 경제와 성장과 소비를 넘어서 인간과 지구와 지속 가능한 미래의 삶의 철학을 정립해 가는 것이 그 무엇보다 중요해 보입니다. 산업화의 도정을 재촉하면서 지구의 탄소의 폐해를 끼쳐온 나라들은 주로 선진국들입니다. 그 길을 쫓아왔던 나라들입니다. 지구에는 수많은 나라들이 생존을 위한 깨끗한 물 한 모금을 아쉬워하고 있습니다. 식량과 주거지 마련에 목말라 하고 있습니다. 풍요로운 나라들이 도움의 손길을 내밀어야 합니다. 개도국이 생존과 번영의 길을 열 수 있도록 도와야 합니다. 유엔은 이를 잘 사는 나라들의 moral duty, 도덕 의무로 규정합니다. 유사한 이유로 자국 내 취약계층에도 시급히 눈을 돌려야 합니다. 지구온난화가 가속화되고 기후재앙이 몰려오면 가장 먼저 그리고 크게 타격을 입는 분들은 취약계층입니다. 나라 안팎으로 눈을 돌려야 합니다. 또 대책도 서둘러야 합니다. 기후과학자들은 지구적 차원에서 2차 세계대전 전후 복구 사업이었던 마샬 플랜과 같은 전폭적이고 거대한 노력이 필요하다고 말합니다. 환경과학계의 거장 레스터 브라운은 몰려오는 기후재앙의 가능성은 전시와 같은 속도의 대응을 필요로 한다고 합니다. 우리 눈앞에서 벌어지는 재앙의 전조에 우리 모두는 시민의식을 더 키워내야 합니다. 정치 해법을 마련해야 합니다. 지금 우리는 과학기술의 진전과 함께 희망의 지평을 넓혀갈 수 있습니다. 어제 와담스 교수님이 자세하게 우리 슬라이드를 보여주시면서 알려주셨듯이 지오 엔지니어링이라는 기술이 이미 우리에게 어베일러블 합니다. 대기 중 이산화탄소를 포집하는 기술이 축적되어 있습니다. 지구에 들어오는 태양열을 관리하는 기술도 진전되고 있습니다. 재생에너지의 역사는 이미 오래전에 진척된 상태입니다. 이런저런 모든 가능성과 함께 미래를 함께 열어가야 할 때입니다. 그리고 이 모든 진전의 선두엔 앞서 말씀드렸던 달라진 시민의식이 있어야 합니다. 정치 변화를 위한 의식혁명이 전제될 때 우리는 역사의 새 지평을 열 수 있습니다. 최근 한반도의 그 어느 때보다 교류협력의 기운이 커지고 있습니다. 한반도에서 유라시아로 이어지는 철도와 문명벨트에 관한 상상력도 고개를 들고 있습니다. 희망과 함께 주의를 기울여야 할 때입니다. 새로운 지역에 종전과 같은 방식의 산업 문명이 또 전개된다면 새로운 가능성은 추가적인 위협으로 변합니다. 지구온난화와 생태계 파괴를 최소화하는 새로운 문명 건설이 필요해 보입니다. 우리 모두 함께 꿈과 희망, 그리고 그 꿈, 희망과 함께 깊은 성찰의 시간을 가져야 할 때가 아닌가 합니다. 고맙습니다.
네, 미래 사회를 위해서 진지한 총장님의 천언을 전달해 주셨습니다. 다시 한번 감사드리고요. 다음은 캠브리지 대학교의 피터 와담스 교수님의 기조 연설이 있겠습니다. 연설의 주제는 지구의 위기와 인류의 미래입니다. 여러분, 와담스 교수님을 큰 환영의 박수로 맞이해 주시기 바랍니다.
Thank you very much. What I'd like to do is to talk about the crisis which President Chue has dealt with so eloquently in his speech, which is that the affluence of every country in the world, including very successful countries like Korea, is at risk because of a combination of factors which are of global scale, which are threatening us all. And it's in my talk yesterday, I focused on climate change, but it's really a complex of problems. That's climate change, resource depletion, and population growth together form a very serious threat to the future of the planet. And I feel that we have to fight this, and there are ways in which we can do it. We don't just have to accept what's going to happen to us. So, first of all, as an outsider who's just visiting Korea for the first time, I wanted to say some admiring things about what Korea has done. That it's been from the way that people from Europe would view Korea is as a highly successful country that's risen from being in a very
serious state after the end of the Korean War to becoming extremely successful in every aspect of industry, leading the world in many, many areas of heavy industry, electronics, shipbuilding, and in such a way that there's now many household names in the world are Korean. And at the same time, this has been related to the development of democratic systems, which have meant that hand in hand with the success of the Korean economy has been the success of Korean society in developing a very open democratic system which can involve everybody, and that plays a material part in the success of the country. So the two go together very successfully in the case of Korea. The question is, can Korea continue along this path, which to some extent has benefited from the availability of raw materials, the presence of peace in the world, relative peace, and are these conditions going to change to the detriment of further progress? And so I'll really try to outline some of the ways in which we are going to be facing very serious challenges, but these are global challenges which have to be answered on a global scale. We all have to work together to try to overcome these, rather than try to work at it individually, in which case we won't achieve the same possibility of success. So if we look at the elements of the global crisis, the first one I'm going to deal with, of course, is climate change, because that's the most immediate and probably the most serious. So can we have the first slide, please? Okay. The Earth's climate has a very interesting history, and for the last million years or so, we've been subject to a series of ice ages, which are driven by. Okay, there's a very faint little laser there. Driven by a series of ice ages, where about every 100,000 years, glaciers build up. Ice sheets grow, and the climate goes down by several degrees. The average temperature goes down by several degrees. We have an ice age. The Earth then pulls itself out of that ice age, and we get to what's called an interglacial, which is the situation we're in today. And it's a very fortunate situation to be in, of course. And the history, which we now know very accurately about the history of the temperature of the Earth because of drilling ice cores down through the Greenland ice sheet and the Antarctic ice sheet. And we can see from the top picture here how the temperature of the Earth follows a kind of sawtooth pattern, that the planet shrinks slowly towards an ice age, getting colder and colder, glaciers building up. And then it stays in the depths of the ice age for a while, and then comes very suddenly out of the ice age. And 10,000 years ago, we came out of the last ice age. I should mention that what drives these ice ages are astronomical factors. It's nothing to do with what we're doing or not doing on the planet. It's very slow fluctuations in the orbit of the Earth around the Sun, small changes which affect the northern and southern hemisphere differently because of the changes in the orientation of the Earth relative to its orbit, and that gives you 100,000-year-long variations in temperature, which are just enough to bring on ice sheets and then take them away again. It's a very critical balance. It's only because the average temperature of the Earth is about the level that it is that we go between an ice age and a non-ice age. We'd either have, normally you'd expect either ice all the time or no ice, but here we alternate. And we're in an interglacial where we've been for the last 12,000 years. And if we look at the bottom graph, that shows carbon dioxide content in the atmosphere, which we can also get from these ice cores by looking at the tiny air bubbles contained within them. And we see that when it's warm on the planet, there's a lot of carbon dioxide, and when it's cold, there isn't so much. And the nasty red arrow is what we've done to the planet since the last 150 years. So we've made a major disturbance to planet Earth. It's like an inadvertent global experiment, and the trouble is there's only one globe to experiment on, and if we mess that globe up, there isn't another one we can go to. Next slide, please. And just the top of this one just shows the factors that produce these ice ages, that the Earth's axis has a wobble. It's like a spinning top that is slightly wobbling and changing its orientation. So the angle of the tropics and the Arctic Circle is very slowly changing. The Earth's ellipticity, the Earth is in an elliptical orbit around the sun, but that ellipticity slightly changes. It stretches and then flattens. And then the Earth also precesses, so the time of year when the northern hemisphere is closest to the sun changes. And those three cycles together give you a slight change in the radiation that reaches the Earth, reaches the north and southern hemisphere. And so we get these cycles, which are called Milankovitch cycles after the discoverer. Next slide, please. Next slide, please. So that's dealt with things beyond our control, astronomical climate changes. But when we look at, we're now in this 12,000 year interglacial, and it's lasted longer than many previous interglacials, but we slowly, just as in previous ice ages, we're slowly sinking towards next ice age. And when we look at the climate record of the last 1,000 years, moving into a short time, that's this one at the bottom, we find that the Earth has been slowly cooling towards the next ice age, which it would expect to reach in about 20,000 years' time. But then suddenly, around about 1850, we see on the right-hand side of that curve, it suddenly starts to shoot upwards. There's something gone wrong with nature. Instead of changing slowly, we've had this enormous boost to the temperature of the Earth, and which can't be explained in terms of natural processes. And the top curve is a kind of expansion of that, showing that it happened in two phases up until 1920, 1930, and then a fallback, and then another phase which we're still in. So why, next slide please. And that coincided with the concentration of the greenhouse gases in the atmosphere, that's carbon dioxide and mainly carbon dioxide and methane, although also nitrous oxide, that they stayed at the same level right from the end of the Ice Age until 1850. So in 1850, which is the modern era, we were on planet Earth with the same concentrations of gases in the atmosphere, trace gases, as we had when the Ice Age ended 12,000 years ago. But suddenly those changed as soon as we invented the Industrial Revolution and started to burn coal and build our entire society on coal-fired power stations, coal-fired locomotives, coal-fired factories. Coal and the burning of coal caused us to put a lot of carbon dioxide and methane into the atmosphere. Next slide. But we didn't know what we were doing. Of course, we don't know what we're doing a lot of the time. But until 1896, there was no theory as to what would happen if you put more of these gases into the atmosphere. And then this paper was written by Svante Arrhenius, who's a Swedish chemist, and I think this deserves much more. It deserves note as probably the most important scientific paper of the last century. And he did the first analysis of what carbon dioxide would do. He calls it the influence of carbonic acid in the air upon the temperature of the ground. So he looked at the absorption of the fact that carbon dioxide in the atmosphere absorbs some of the outgoing radiation from the sun, and by holding that back, outgoing radiation from the Earth, sorry, and holding that back means that the Earth warms up inevitably, and the more carbon dioxide in the atmosphere, the more the Earth warms up. But he calculated how much it would warm up and got results which are very similar to what we know today, except he didn't think it was a global problem because he thought all that extra heat would be absorbed by the ocean and we wouldn't notice it. So it got less notice than it should have done because he really wasn't banging the drum about the seriousness of global warming. He didn't think there would be global warming, but he thought the atmosphere would warm, but the heat would be absorbed by the ocean. Next slide, please. Then, of course, things did change very rapidly as a result of that warming, and we noticed, first of all, that they changed very rapidly in the Arctic with the sea ice retreating from earlier positions in summer, shown by the pink lines, to the more recent positions shown by just the white outlines. And those are very large changes to the area of ice on the planet. They are like changing the face of the planet. It now actually looks different from space. If you look at one of those lovely pictures of the Earth taken by astronauts, there's more blue stuff at the top end than there was in previous years. Next slide, please. And it was calculated by a group in University of California that this loss of ice, which is the area shown in blue on the bottom here, which is what we used to have is the white area. What we have now is white minus blue, and the blue, which is now open water and didn't used to be open water, is the area that gives us an increased amount of warming due to the fact that the surface of open water has a very low albedo. That is, it absorbs 90% of the radiation falling on it from the sun, while an ice-covered surface reflects about 90%. And so that albedo, called an albedo difference, is so huge that it affects the whole planet. And their calculation was that over the whole planet, it's as if we added a quarter to the amount of greenhouse gas release we're doing. The extra heating is that high. But now we think it's actually a half rather than a quarter, because snow is also retreating in the northern hemisphere, and the difference there gives you another quarter. So we are by adding carbon dioxide to the atmosphere, warming the atmosphere, causing ice and snow to retreat, we're then accelerating global warming, because the albedo change is equivalent to adding a half to the amount of greenhouse gas that we're putting into the atmosphere. Next slide, please. This has many other consequences that can be very nasty. We don't know yet how nasty. One of them is that big areas of the Arctic, that's shown here as the East Siberian Sea and Shelf, these areas are very shallow, and if sea ice retreats from these areas, the seabed warms up because the solar radiation reaches the bottom, and we get warming that can detach permafrost from the seabed and release what lies underneath, which is a frighteningly large amount of methane gas contained in the sediments. If all of this methane gas were released in one go, we'd have a very large methane pulse that would give us an unendurable pulse of warming. Even if a few percent are released, we could get easily more than half a degree of warming very suddenly with the methane gas bubbling out of the Arctic coastal seas. Next slide. And this is already happening. not to the scale that gives us a massive warming, but to the scale where you can see what's happening. And this is showing some methane plumes like this from the East Siberian Sea. And if you're investigating this, you have to be careful sailing over a plume like this, because this methane gas is combustible and your ship might blow up. Next slide. These are two of the effects of global warming. But another one, which is one I didn't mention yesterday, is the fact that it alters the course of magnitude of ocean currents. And most ocean currents are wind-driven, and like the Gulf Stream, the Southern Ocean Current. But there's a slow current system operating worldwide called the Thermohaline Circulation, or it was labelled the Great Ocean Conveyor Belt. It's driven by temperature variations and salinity variations. It's a very slow circulation, and it happens on the surface and deep down as well. And it takes about 1,000 years for a little parcel of water to completely circulate around the planet in this circulation. So that, for instance, if you were a Viking explorer in Greenland and you dropped a battle axe over the side of your ship, then in the year 1000, it would just be reappearing off the coast of Greenland now. But this circulation is driven by events at the northern and southern limits of the world, and one of them is production of ice in the Arctic, which drives the seawater to become more dense and make it sink. And that's now stopped happening. So we're getting a reduction in this circulation, and we've already measured that, which means that circulation in the Atlantic helps the Gulf Stream. It adds to the strength of the Gulf Stream. And without that, we'll have a slower circulation in the Atlantic, less heat reaching Europe, Western Europe, and more heat remaining in the tropical Atlantic, which means giving rise to much more intensity of hurricanes. And again, we're already seeing that hurricane intensity depends on water temperature. The water temperature in the tropical Atlantic is going up very fast because the water not so much of it is moving up towards Europe. And for Europe, the predictions are that Western Europe that's receiving this water will not exactly cool down, but warm up more slowly. And by the end of the century, you can expect perhaps 2 degrees of warming. This is unfortunately not the Paris scenario where it works and we keep the world within 2 degrees. It's the pessimistic scenario where we don't do very much and we get about 4 degrees in most of the world, including most of Europe, which means bad news, therefore, for southern Europe, which will become rather like North Africa. But the west coast of Europe will only get about 2 degrees of warming because of this effect. Next slide, please. So that's a quick rundown of some of the phenomena, but the one phenomenon that interacts with everything else, that is the problem of resource depletion and the problem of population, is the weather extremes and the way that they've been affected by climate change in fact, in the Arctic again. The Arctic always seems to be the villain here. And the President had talked about this in his speech this morning, that what we're finding is that there's a wind system called the jet stream, which separates the air over the Arctic ice cap, the air over the center of the Arctic, from subtropical air. And it's the blue wiggly line at the top there is just a representation of where this jet stream lies. And it's a very strong eastward flowing wind. It's a west wind flowing east. And it separates this tropical air or subtropical air from polar air. And it's a very strong wind because if you're flying around the world, it depends which direction you fly in, whether you're helped by the jet stream or not. But that jet stream has got weaker because it's driven by the temperature difference between the polar air and the subtropical air, and the polar air is warming much faster than the subtropical air, this effect in the Arctic that it's warming quicker than anywhere else. So as that temperature difference goes down, the driving force goes down, and the jet stream gets weaker. And when it gets weaker, instead of... next slide, please. Wow. Okay, instead of being in a straight line, it starts to develop these lobes. And I think there might be another one of a lobe. Can you try another slide, please? Okay, that's got a better lobes. What happens here is that this polar air mass is able to move down to quite low latitudes in particular longitudes. So here in eastern United States, we find it coming down to pretty subtropical eastern United States. In the middle of the continent here, the warmer air moves up to a latitude it shouldn't reach, like the Canadian prairies, which are normally pretty cold in winter. And so if we go around the world, we get to alternating zones of extreme heat and extreme cold that we didn't used to have, because with the jet stream not being in this lobed form, we'd have a normal sort of seasonal climates. But now we're getting either extreme heat or extreme cold. Next slide, please. Oh, there it is again. Okay, next one, please. And we noticed that for the last 10 years this has been noticeable. And every year there's been this weather extreme. So people are starting to say, well, it's a climate extreme, because when the same weather pattern happens for several years running, you realize it's actually a new climate pattern. And in America, they're used to having these either extreme cold spells or extreme hot spells. But in Europe and in Asia, it's also happening. This is a European case, and I know you've had this in Korea with an extremely cold spell early this year, an extremely hot spell this summer with record-breaking temperatures. But in Europe, we had a similar thing right early in the year. We had an extremely cold spell, and this was the mean temperature of Europe, because it was much colder than usual, but of the Arctic at European longitudes. That's the Arctic in northern Europe, north of northern Europe. And that red curve shows the temperature of the Arctic during these first few months of 2018, which was about 20 to 30 degrees warmer than it normally is. And that was pretty extreme. It meant that in January, you had warmer weather in Spitsbergen. You had snow melting. You had temperatures well above freezing point, even though it's the middle of the winter in the Arctic. And again, it's because of this jet stream effect that of these cold and hot lobes. Now, the trouble with that, next slide, please, is it's an explanation, but it doesn't hold out any comfort for us, because it means that since this is resulting from the warming of the Arctic relative to the tropics, it's a phenomenon that will keep on happening, maybe getting worse and worse. And the bad effect of it is that these extremes of heat and cold impinge on crop production, because they're happening at mid-latitudes, and the mid-latitudes are where we grow all our crops. The brown areas here are areas of in crop production, and of course we have crop production in the tropics and in the southern hemisphere, but the biggest production zone is Canadian prairies across to the US, Europe, Ukraine, steppes of Russia. All that lot are all in these latitudes which are affected by this these Gulf Stream lobes. Jet stream lobes. Next slide, please. So crops are threatened, and when crops are threatened, the price of food goes up. And the FAO, Food and Agriculture Organization, produced a World Food Price Index in the year 2000, which was an estimate of what the average price of food is worldwide, which is very difficult to arrive at, but they did their best and came up with an index. And it started at 100, but by 2008 it had risen to a peak of 220. So food on average in the world was more than twice as expensive in 2008 as it was in 2000. And not coincidentally, there was massive amounts of social unrest and civic unrest at the Arab Spring, for instance, during that period, because a lot of that unrest develops in third world cities where people are living in poverty, they can't grow their own food, and the price of food means a lot to their survival. And so they get very, very, very upset if they can't buy food. And so there was a big outbreak of these problems in 2008, and then again an even higher price was reached in 2011. And these corresponded to years actually when there were very low amounts of ice in the Arctic. So it was not coincidental, but the extreme weather events were causing disruption to food supplies in those 2 years to an extreme extent. And things went down a little bit since then, but we're still over 200 in comparison to the start of the century. So food prices already double what they were only 18 years ago, and that makes life difficult for everybody, and it's not likely to get any better. Next slide, please. I was just saying, this was to remind me to say that when this happens, it makes life very, very difficult for people who are suffering the most, which is poor people in urban environments. And this polar bear is here because I photographed it when we were landing on a big iceberg in Baffin Bay, and the iceberg had 30 polar bears on it that had got marooned on the iceberg because the sea ice retreated and there was water all around the iceberg. They couldn't swim off, so they were stuck on the iceberg. And then when the scientists arrived, and we tried to land by moving the ship against the iceberg. Every time we tried to land, a polar bear would come very close and sit there expectantly, thinking this was a chance to get some lunch because it hadn't eaten for some very long period. And so this polar bear symbolizes the human race. If you're dealing with crop failure and lack of food, high price of food, and you can't do anything about it because it's not your problem, it's not in your part of the world, but you suffer, then you're a bit like this polar bear. Next slide, please. Although hopefully you don't eat people, but anyway. Then leaving aside the problem of actual crop failure due to weather variations, there's the fact of the actual warming that's taking place. And again, as the President pointed out, one of the reasons for taking the 2 degrees as the preferred target for maximum warming is that beyond 2 degrees of warming, you start to get very significant crop failure, or reduced crop yields anyway. So these are 5 of the main food crops grown in the world, and we can see, if you look at the left-hand scale, the percentage losses beyond 2 degrees start to mount up, and beyond 3 or 4 degrees they're disastrous. So it means just designing a completely different set of crops for the planet if we don't rein in global warming. Next slide, please. And the other thing is the population crisis, which again people started to forget about. There was a wonderful book written in 1972 called Limits to Growth, which was an analysis of an attempt to analyse the future of the planet, looking at the interaction of population, pollution. They didn't really consider climate change because it hadn't been studied enough then, but it was ignored a lot. Nowadays people tend to ignore it because one of its conclusions was that there would be a lot of starvation going on, but within 20 or 30 years. That didn't happen because of the Green Revolution. It meant science came up with higher yield crops, and we were able to fight off the possibility of mass starvation. But we can only fight it off for a certain length of time, and the fact that people have forgotten about climate change, about population as a factor in world problems, means that the population is accelerating in ways that we don't even understand. And there's one that I don't understand, which is Africa. Here, the left-hand column is present populations of different zones of the world in millions. The right-hand is the predictions by the UN World Population Programme of what the population will be in the year 2100. And mostly they're showing average kinds of they're all showing increases except Europe, but they seem to be increases that we can cope with, but not Africa, which is set to quadruple in its numbers in a continent which is finding it very hard to grow enough food now to feed its present population. And so how it can feed 4 times as many people is something I just don't understand, and I don't understand the real background of that figure. So I think that would need to be investigated as to whether that's a real number or whether, because if it is, there's a frightening future for the population of Africa, that it will be dependent almost entirely on overseas aid. So that's another problem that we have to deal with, and which is there, and we haven't dealt with it, and we haven't even considered it. And so the numbers of people trying to get onto boats and go to Europe from Africa, the number that are doing that now is tiny compared to what will happen in the future. Next slide, please. So what we can do about this is eventually there has been agreement on on reducing carbon emissions. The rise in temperature in the planet is due to adding carbon dioxide to the atmosphere, and methane. But that's obvious, although some people still deny it. But since that's the case, how can we prevent that from causing catastrophic warming that will make the world uninhabitable for us? And the only 2 ways are to reduce the emission of carbon dioxide, to stop producing the stuff, or to get rid of it, rid of the stuff that we have. And reducing emissions looks as if it ought to be the solution, and this is what's being done by everybody at the moment. They're driving smaller cars, using renewable energy instead of fossil fuels. There are very creditable efforts being made everywhere to reduce CO2 emissions. And the trouble is that, first of all, they don't seem to have had much effect. Next slide, please. If we look at global emissions of CO2, China and India are still rising very fast. Europe and the USA are coming down slowly, but adding them all together, there's still an increase. So the emissions are still going up. But what's worse is that the content of carbon dioxide in the atmosphere is going up even faster because the carbon dioxide doesn't go away. Methane, for instance, goes away after a few years. It oxidizes in the atmosphere. But carbon dioxide stays around in the climate system. It may get turned into plant life or get dissolved in the oceans, but then it comes out of the oceans, the plants get burnt. It cycles around for hundreds of years. So a given molecule of carbon dioxide that's produced from your car exhaust, it will still be around somewhere having a climatic effect for hundreds of years from now. So we're dealing with a ratchet effect. We add any carbon dioxide to the atmosphere, it stays and adds to the global warming effect. So it's sort of almost like saying we should give up, but it means we can't depend on reducing emissions to actually get us down to a livable level. We have to find ways to actually take it out of the atmosphere and get the atmosphere back down to the state it was in for the last 12,000 years before we started to do all this to it in the 19th century. Next slide, please. So various methods have been suggested to do that. There's an interim set of methods which could be very useful and important, and I think we should be developing and trying them. That's to increase the amount of energy reflected straight out of the planet, make the planet brighter, in other words, and that will cool us down or stop us from warming. So we can control warming that way, although we're not controlling carbon dioxide levels, and they will have a continuing effect, which is very bad because it will involve, for instance, acidifying the ocean. But we can at least get the temperatures down, and the methods that have been used include putting sulfate aerosols into the stratosphere, and they then reflect radiation back out into space. Or another method, which I think is more attractive because it's less poisonous, is called marine cloud brightening, where water is pumped up masts into the bottoms via a very fine nozzle, which breaks it up into tiny particles only a micrometer across. Those particles are injected into the bottoms of clouds, low clouds, which occupy about half of the ocean surface, and brightens those clouds, and that's been observed to happen. And so that brightening effect increases the albedo of the cloud, and we get a reduction in an increase in the amount of radiation reflected. That's a method that's been developed in great detail. Next slide, please. By engineers, starting in a group in Scotland started it off. And so they envisage a fleet of unmanned drone ships, computer controlled, that will drift around the ocean in places where you want to do this treatment. The cylinders are actually flettner-rotors, which provide propulsion, but the water vapor that comes out in these tiny particles gets into the cloud and brightens them up. So you have a fleet of these. The design of these ships and the theory and the practice of how tiny particles of salt water brighten up clouds, that's all been very well developed. So, however, there hasn't been any serious money spent on taking this through the development stage and actually starting to implement it. So this is where there's a chance at moderate cost to achieve a real impact on global warming. So that's what I was suggesting in my text, that this is a project that Korea might take up, because it's the scale that can be done by an industrialized country. Korea has many advantages. For instance, they could build the ships that are needed, and it would be really important for the world. Next slide, please. But in the end, the problem is this doesn't deal with the acidification of the oceans, which could get bad enough to wipe out marine life, because at the moment, the way the world gets rid of CO2 is it gets incorporated in the shells of small marine animals like foraminifera, and when they die, they sink to the seabed and it's lost. So we're saved. But if there were more acidification of the oceans, these shells would dissolve in the water, and the carbon dioxide goes back into the system, and so that would be a disaster. Next slide, please. So in the end, what I would see as the only answer for the planets and dealing with the greenhouse effect is going to be actually getting carbon dioxide out of the atmosphere directly. And there are research projects to accomplish this, and it's fairly simple science, because you just have to have big blowers passing air over a substrate which absorbs carbon dioxide, and then chemically, and then you heat that carbon dioxide, that material, take the carbon dioxide away and pump it down into a coal mine or something, and then you start the process up again. It can be done, and there are already three pilot plants in operation in the world, doing very small amounts, one in Iceland, one in Western Canada, and one in the USA. But it is the only ultimate answer. So it's a scandal, really, that it's a small-scale operation by three small companies that don't have much funding, whereas what that should be is what the president described as a Marshall Plan, and I used to describe it as the sort of a military operation, but I think the Marshall Plan is a better word, because it's designed for peaceful purposes, and this would be on a scale that would develop and support methods for taking carbon dioxide out of the atmosphere, and apply them as well, that when we can get the process to be cheap enough so that the cost of taking the carbon dioxide out of the atmosphere is less than the damage that carbon dioxide does, then we should at that point apply it worldwide. But that's just the point where people will have to be asked to pay for it. And how do we get the world to pay for something like that when they're undoubtedly going to be reluctant to do so? So that's a big problem where we need to have a more enlightened population to say, if we can get this thing working, please can we employ it worldwide to save the world? Otherwise, the world is lost. So we hope that will be the education process of the future, is to say these little projects that are being done now are actually the key to the survival of the entire human race, and we must be scaling these up and applying them worldwide. So, and that's where I guess the peace comes in, because as the President has said, that you will only have peace if populations can live together with reasonable living standards, but also sharing some shared aim of making a better world, and the shared aim of making a world which is free of climate change and will enable the population to continue to survive and civilization to survive. That should be a worthwhile aim in itself, which hopefully will prevent people from being at each other's throats, and will help them to work together in a peaceful way. Thank you.
Professor Wadams, maybe you probably may get back to your seat. Yes, please. Thank you very much. 매우 중요하고 또 깊은 통찰이 담겨 있는 강연을 해주신 와담스 교수님께 여러분 다시 한번 박수를 부탁드리겠습니다. 네. 다음은 세계 평화의 날을 기념하기 위해서 음악대학의 헌정 무대가 있겠습니다. 잠시 무대를 정비하는 동안 기다려 주시기 바랍니다.
여러분 반갑습니다. 저희는 음악대학 교수진으로 이루어진 현악 사중주 연주팀입니다. 안녕하세요. 네, 저희가 들려드릴 곡은요. 독일 작곡가 멘델스존의 현악사중조 1번입니다. 그래서 멘델스존이라는 작곡가는 어떻게 보면 음악사에서 음악사를 통틀어서 봤을 때도 굉장히 드문 케이스의 작곡가인데요. 부유한 집안에서 태어나서 일생 동안 부와 명예를 충분히 누리고 갔던 작곡가입니다. 그래서 어떻게 보면은 뭐 가난에 시달렸던 모차르트라든지 정말 고난과 역경을 딛고 일어선 그런 베토벤처럼 드라마틱한 스토리는 없는 작곡가입니다. 하지만 일생을 경제적인 어려움이 없이 살았기 때문에 순수하게 창작력을 불태워서 수많은 명곡을 탄생시켰습니다. 그래서 오늘 들려드릴 현악사중조 1번은 특히 멘델스존이 평화로운 그 일생 가운데서도 일에 있어서도 큰 성취를 이루고 또 사랑도 시작하고 굉장히 행복하던 가장 행복한 시절에 작곡된 곡이기 때문에 멘델스존 스스로도 이 곡을 굉장히 아꼈다고 하고요. 곡 전반적인 분위기가 굉장히 따뜻하고 행복한 기운이 많이 묻어나는 곡입니다. 굉장히 평화롭고 저희 피스바 페스티벌의 어떤 전통과 피스바 페스티벌 취지를 생각하면서 저희가 평화로운 마음을 담아서 연주해 드리겠습니다. 그리고 뒤이어서 성악곡 2곡 들으실 텐데요. 그 곡들은 저희 음악대학 소프라노 박하나 교수께서 나와서 또 설명드리고 연주 들려드리도록 하겠습니다.
네, 안녕하세요. 소프라노 박하나입니다. 제가 총 2곡을 준비했는데요. 첫 곡은 여러분들 잘 아시는 핸델의 오페라 리날도에 나오는 아리아를 준비했습니다. 이 곡은 여주인공 알미레나가 납치된 후 감금된 후에 자유에 대한 갈망과 그리고 자비를 구하는 내용의 아리아인데요. 특히 영화 파리넬리에 나오게 되어서 굉장히 널리 알려진 곡으로도 유명합니다. 두 번째로 준비한 곡은 한곡 가곡 신아리랑을 준비했습니다. 이 가곡은 김동진 선생님께서 작곡해 주셨는데요. 특별히 김동진 선생님께서는 우리 경희대학교 음악대학 학장을 역임하셨고 주옥 같은 가곡이죠. 목련화를 작곡하신 분이시기도 합니다. 제가 부를 신아리랑도 선생님이 우리 고유의 것을 온전히 음악에 담고자 하셨던 선생님의 음악적 철학이 잘 담겨져 있는 노래입니다. 즐겁게 감상하시면 감사하겠습니다. 감사합니다.
네, 본 기념식을 더욱 빛내주신 음악대학 여러분께 다시 한번 감사의 말씀을 전합니다. 이것으로 피스바 페스티벌 세계평화의 날 기념식을 모두 마치도록 하겠습니다. 오후 1시 반부터는 특별 강연과 또 총장님께서 참석하시는 원탁회의가 진행될 예정입니다. 많은 참석 부탁드립니다. 지금 3층에 리셉션이 준비되어 있습니다. 그래서 귀빈들과 함께 여러분들 즐거운 시간 가지셨으면 좋겠습니다. 이것으로 기념식을 모두 마치겠습니다. 여러분 대단히 감사합니다.